Welcome everyone. After posting my idea of adding viruses to the Bibit simulation, you guys went nuts. So obviously, I got to work. Just maybe not to the Bibit's benefit. But first of all, I want to stress that this video is not to be taken as an argument to anything related to the real world. It's just a fun thing to play around with, but that's all. That being said, let's follow my progress in developing this. First, we have the virus, which is an entity with genes that can evolve and change behavior, but need to infect a Bibit to reproduce and function. Once they infect a Bibit, they will spread through its cells in a manner that will seem very familiar. Initially, it starts exponentially spreading through the cells, and this growth gradually tapers off as it sees less and less cells to infect. This is called a logistic function and is usually how we model exponential growth with finite space or resources, like the spread of a virus inside a population. But it's quite interesting to see that the same behavior is displayed inside one individual. One gene the viruses have is the replication rate. This will influence the speed at which they will spread inside their host. A high number means that the virus replicates and spreads faster. This is the number that we usually want to drive down when we say flatten the curve. Although usually that number is not just genetic and takes into account the environment where the virus operates. Another gene is the incubation delay, which dictates the incubation period of the virus. It will influence for how long the virus stays dormant in the host before it starts spreading. Simple enough. Of course, it would be a little boring if the virus had no effect on the Bibits that's infected. So, I added 3 genes, the damage rate genes for health, energy, and immune. The effect of the first 2 are pretty obvious, but we'll come back to that third one later. They are all also disabled under a value of 1 to simulate spontaneous evolution, allowing the genes to turn on and off more discreetly. They play an evolutive balance where the actual values are not important and instead their respective proportions are. And just because in science you can name things, I decided to call this a weighted apportionment genetic group, or WAGG. And a big thanks to Professor Charles Ofria for helping me come up with that acronym. The actual total damage done is dependent on the production of new viruses and is then split according to those proportions. I also chose that by default, damage would be done to health. Because cruelty. Now, we have to make sure that the virus can spread between Bibits. When spreading, the virus can use those newly produced variants in 3 different ways. Just like before, this is a weighted apportionment genetic group. Or again, WAGG. And the 3 possibilities are spreading through cells, to skin, or through the air. Cell spread is pretty much what we discussed earlier, where the virus spread through more cells inside the Bibits. So let's focus on the next 2. First, when spreading to the skin, viruses will accumulate in a thin layer on the Bibit skin. This is not really analogous to anything real viruses do, but bear with me, viruses in this universe do. It can then spread through contacts if a healthy Bibit and an infected Bibit collides. There is then a chance for it to spread that's proportional to the skin's infection. The chances are also higher if the contact involves one of the 2 mouths, and even higher if one of the 2 Bibits is biting the other. Quick digression, to make the sickness effect for this simulation, I decided to learn how to use shader graph in Unity. I'll go over it fast to not bore anyone too much, but basically, I just generate a pixel grid from the screen UV, scale it to be the same pixel size as the original sprite, transform it into a noise texture, make it move with time, take the original sprite and shape the noise texture similarly, and finally blend between the 2 depending on the skin spread. It was a lot of fun and I look forward to playing with it more for other things. Back to the main subject. Then, the virus is also able to get to the air and spread. When doing so, they produce little virion particles that are essentially floating virus bubbles and can infect other Bibits. By the way, that was my first time playing with animated sprites, and it was pretty fun. It's interesting to think that maybe I could use this acquired knowledge to try my hand at
animated procedural sprites
when I'll get there, but oh well. I don't know if I'm being too ambitious, but I like having crazy ideas and pursuing them. The last thing remaining is to look at how the immune system of the Bibits works. Basically, the Bibits now have one additional sense and one additional output action node that they can evolve to use, as well as a gene. You can watch my previous videos if you want to see how their brain works. Basically, that gene will determine the ground activation level of their immune system and how up-to-date they are about their current infection level. That's where their new input node comes in. They are now able to sense their infection level. And it works a little bit like this. Their perceived infection state is delayed in relation to reality to simulate a sort of lag in inertia. The actual lag is then decided by that previous gene, which has the added cost of increasing the energy to health ratio and increasing the cost for the Bibit to grow by a small amount. And then we have the output node, which dictates the activation level of the Bibit's immune system. The immune system combats viruses and gradually cures cells of their infection, making them immune to reinfection. Of course, the downside is that an active system costs energy to maintain, albeit a small amount, and that if too active, healthy cells are damaged and hurt during the process. Up to the point that the full immune system activation is extremely dangerous and would be akin to a cytokine storm in the human body, being almost always fatal. As a result, Bibits will have to learn to deal parsimoniously and prudently with their immune system. An active immune system will also help in getting a more accurate perceived infection level. That's also where the immune damage we previously discussed comes back. While doing immune damage, the virus will fight off some of that immune response, delaying the perceived infection of the body and gradually clearing off cured cells to be infected again. So yeah, I think that's pretty much it. I made this marvelous diagram to try and display the whole system. If I summarize it quickly, you have the virus that infects a Bibit, which is represented by the infection level. The virus then induces the creation of new virions and well, I guess you've just seen the video, so I'll just leave it there for now, but you can come back to it if you ever need to refresh your memory, if ever. Let's just agree that this makes for a very complicated and dynamic system. The only part we didn't really explore is the behavior of the Bibits in response to that new threat. We've seen that they now have access to a new gene, as well as a new brain input and new brain output. So you might say,
but how will they evolve and use those?
Well, I figured that this video is already dense enough, and I've already been working on this for the past 3.5 months. Oh my god, what am I doing in my life? Yeah, this upload was way overdue, so my next video will focus on the impact of the virus on the Bibits and their simulation, like how they evolved to adapt to that new reality, as well as a few other additions. I usually upload versions of the simulation for free on itch.io so you can run it yourself, but as of now I don't believe the update to be ready, so I'll upload it with my second video. In the meantime, earlier versions are still available on there if you want to try it for yourself. Make sure to subscribe to the channel if you want to be sure to be notified when the next video comes out and this version of the simulation becomes available. Of course, my patrons have access to the alpha version as I develop them, but they often are far from stable. Talking about my patrons, I can't thank all of you enough, so with the help of a few collaborators, mainly Brax and Mr. Tin, I decided to do something special. So for the next few minutes, enjoy a simulation where they are the true stars.